Thank you, Tavi, as well. Yep. So my name is Cosmin Pascu. I'm a solution architect within AWS Romania. I've been here with AWS Romania ever since we've opened our Bucharest office 2 years and 10 or 11 months ago. Amazon has had a presence in Romania, as you know, for these development centers ever since 2006 in Iași, then Bucharest, then Timișoara after we acquired Ring, now Cluj as well. But Amazon Web Services as a business entity that supports Romanian customers and users, we've been here for, I was actually the first external employee in AWS. And I'm here today to discuss how you can quickly infuse generative AI within your applications. It's in the name, right? Amazon Web Services. That's what we did. We allowed for infrastructure to be there at an API call, and that's what we're doing right now for generative AI. Let's see.
Try the black one, the other one.
Oh, okay,
the other
sorry.
clicker. Yeah.
All right, it works now.
Good.
So the agenda, we start with the challenges, what we have seen through the market, what were the challenges in building products based on ML or AI technology. And then I talk a bit about how AWS plans to solve those challenges through its services. Some use cases, we've been discussing use cases throughout the day. I have left actually the customers part outside of the presentation. I don't want this to be a commercial one, but we can talk about the references we have for the services we will cover here one-to-one afterwards. And then how do you actually get started with generative AI? Yeah, so we've been talking about generative AI throughout the day, right? But for those of us who have been invested in this space for the past years, this really, doesn't feel really new. We were like maybe taken by surprise, but what has been happening within the past year when it has entered the mainstream. But we were there, right? I was looking at, we were there for Word to Vec, we were there when attention is all you need, paper dropped, we saw transformers. I thought that, this is like NLP having its ResNet moment for computer vision. This was how it felt for me. Hugging Face came out, it sort of democratized access to models and everything. And what has happened this year is like we have seen what generative AI has evolved to, right? The fact that they can perform so many tasks because they contain such a large number of parameters, and they were able to make them capable of learning complex concepts and to apply them in ways that even maybe the creators hadn't thought about it, right? So this has really sparked up the public's interest into it. But the real value comes when you customize these large foundational models for your organization's tasks with your organization data. And we've been discussing use cases. So multiple use cases here. We had chatbots, right? Those were a thing beforehand, but now they're much more natural and much more capable. Virtual assistants such as Alexa. Alexa has been powered by over 30 machine learning models. Now it's getting infused with a large learning model that will allow her to have like more deep conversations, such as, there was the Champions League matches last night. Okay, you can talk about the matches and be much more conversational. This has been announced in a keynote on our Amazon devices, I think last week. You can have AI-powered contact center. We have a solution for that, Amazon Connect. We have built it for our Amazon.com business, and it's now like a contact center as you go, and you get sentiment analysis on call transcripts. You get routed to the various operators that fit your use case based on call transcript analysis and so on. Personalization. I think Amazon.com was one of the first big players in retail business that started using personalization algorithms within its website. So, as I've said, we have a strong pedigree in machine learning. We've been using that in our fulfillment centers, computer vision with Amazon Go and so on. Employee productivity. This was, I think, what captured our attention, right? We're all developers here, and I was really amazed when the foundation models came out, one of my customers was like asking for a snippet on how can I use Amazon simple email service to send out an email based on a CSV file I passed as parameters. And like 2 years ago, I would have sent him the link to our documentation. This is our SDK. This is how you do it. Good luck. Go and do it because it would have been like maybe a half a day work or the full day work. Now it took me like 5 minutes using our Code Whisperer. It's like our tool for developer productivity and code generation to like do a sample code that does just that, and I've attached it to an email and say, this is for demonstration purposes, go test it in production. But we've seen what happens to productivity. Creativity and content creation, we've had that session in the morning. We've seen how quickly marketing and marketers can generate content. And of course, the boring part, improve business operations. What maybe intelligent document processing, process optimization. There's actually a whole team of data scientists in Bucharest within the Amazon.com data science team that really focuses on that. So if you want, there's state-of-the-art NLP research done in Bucharest on intelligent document processing. We can talk afterwards in one-to-one settings. But building this sort of applications, it's pretty difficult, right? It comes with its challenges. The speaker before me told you about the challenges in the life of a data scientist, right? So you always get newer versions of the foundation models. The foundation models get updated and come out at a rate that, for the past months, it feels almost impossible to keep up with. I was in vacation for 2 weeks, and when I came back, like, it was a whole new ecosystem out there. Customizing foundation models is complicated. It got easier. Like, you have libraries and frameworks, you have LoRa, you have PEFT. It's way easier than it was 2 years ago, I would say, right? But it's still, you need to learn the ecosystem around this new thing that's happening. Maintaining data privacy and security, that's always important, especially in the enterprise. I work within the enterprise segment, that's why I'm an enterprise solutions architect. Getting foundation models to execute tasks, right? To actually use them for something rather than just chatting with, right? You want to use that power that they have, that reasoning power to help automate things in your business. Connecting foundation models to external data sources, that's also another task in its own. And of course, managing the infrastructure underneath it. There was that really cool graph that the speaker before me has shown where the ML code is just one part of the whole software infrastructure. So these are the challenges. And in Amazon, we listen to how we develop services and products within Amazon, and actually how we do things internally as well. We look at what our customers are saying, we look at the challenges they're having, and that's how a new service gets proposed and then gets accepted, and we start working on it. And Amazon Bedrock, this was a thing that we've just launched. It has been made generally available last week, actually. I think last Thursday or last Wednesday. It's been in limited preview for some months right now. We've had customers in Romania actually testing it, but it's been GA last week. And it allows you to access multiple foundational models, to choose the one for you through a single common API. You can customize your foundational model with your own data and fine-tune it for your use case, for your organizational culture, and your specific data. It enables the data security and compliance that people have come to know and respect and trust AWS with, right? It runs within the same security constructs as you know from AWS. You can build agents that execute those complex tasks for you and invoke APIs and get access to your organizational data, right? And you don't manage any infrastructure. It's, as we call it, serverless. We take care of the infrastructure. We take care of the infrastructure that trains the model, that runs inference on the models. We do that either on NVIDIA GPU chips. I think we're the oldest partner of NVIDIA in the hyperscalers business, right? We've been partnering with NVIDIA for 12 years. We're the first cloud vendor to have NVIDIA GPUs within their cloud platform. But we're also training and running models on our custom silicon chips that we develop. We have AWS Trainium processors for training data models and AWS Inferentia custom developed processor for running inference. I said that Bedrock supports leading foundation models, and we believe that for each use case, there is a model that best fits that specific use case. So we have there Titan, which is our Amazon model. It's very good for text summarization, generation, information extraction, embeddings, search. You can test out Jurassic 2 from AI21 Labs. Claude 2 from Anthropic. It's a very interesting model. We have signed last week, I think, a strategic partnership with Anthropic. We have invested in them as well. We have, they will use AWS to train and run inference on their models moving on. So Claude 2 is very interesting for its context size. So you can load up huge PDFs and documents within it and do like semantic search and whatnot. Cohere is a model that's very good for embedding. It allows you it has a very powerful embedding model. I think everybody knows the Llama 2 models from Meta. They're very fine-tunable, I would say. They're very well, there's a whole community built up around them, and they're coming soon to AWS, to Amazon Bedrock as well. And Stability AI for text-to-image or image-to-image generation. You can run stable diffusion on Bedrock with a single API call. So this is how the dashboard actually looks like, right? When you click through the dashboard, you can choose from the foundation models you want. There's a playground to test them out, whether it's text or image, and you can orchestrate them using, as I've said, agents or building up your organization knowledge base. But let's say the console is just for demonstration purposes. I guess no one really runs it in production use cases. So we will look at how you actually work with these models at an API level. As I've said, foundation models alone cannot execute tasks. I mean, they are there to help you out in your day-to-day business, like virtual assistants. But if you want them to help you automate your business tasks, you need to orchestrate them. And we've come up with Bedrock agents to allow you to do just that. You select your foundation models, you provide it instructions, select the data sources it has access to, and you run actions that call out those APIs. You load up an API schema in open API format, and yeah, who can guess how do you actually interact with those APIs? It's right there. It's with Lambda functions, basically. So you write a Lambda function, and you instruct the model to run that Lambda function and reach out to your API. Again, it's fully managed. This can be done, it's based on a paper, I don't have it linked here, but it's a technique called React, Reason, and Act. So basically, we do some prompt engineering to keep the context for the large language models, to be able to keep the same context and orchestrate the task and so on. So you could do this using the techniques described in the React paper. But we do that for you, right? And we manage the full infrastructure for you, and we use the same, let's say, tools that you know from integrating your applications, right? What else? Data, right? Data is the differentiator for your business, and this is how you actually get business value out of your machine learning. And one way to do that is by running fine-tune algorithms on the model. So you maximize its accuracy for specific tasks, and you only need a small number of labeled examples. So with Bedrock, basically, You don't have to annotate large volume of data. You just upload your data set to S3. You get a copy of the base foundational model for you that it's fine-tuned, so none of your data, none of your organizational data gets sent back to Amazon or to the third-party models, and it's not used for retraining the original base foundation models. Basically, you just place in S3 your data set for train and for validation. It should be in a JSON format that follows like input text, output text. We recommend 10K training records, 1K validation records. There are some hyperparameters you can set with regards to how many epochs you want it to run, batch size, learning rate, and that's it, right? There's no need for you to, I mean, you can still run your fine-tuning algorithms if you want and so on, but you do that in our other service, in SageMaker, which is the ML AI platform that allows you to run experiments, you have your Jupyter notebooks there, everything else comes in for data scientists, comes within SageMaker. This is for developers and for people who quickly want to experiment and productize machine learning applications. After you load up your fine-tuning data, you get a new model. As I've said, it's your own private model. You can find it in the playground, or you can invoke it with the API. You get a separate new model ID, and that's what you call out to talk with your finely-tuned model. But fine-tuning is just one way of actually using your organizational data. The other is a technique called retrieval augmented generation. I don't know if you pronounce it RAG or RAG. I especially write in English. Like I say MySQL in English, but I say MySQL in Romanian. So I will go with RAG, I guess. So this allows you to connect your foundation models to your data sources. Basically, it's another. You put out your data over in S3. Right? You run Titan embeddings or Cohere embed to generate vector of that company data you have in S3, and that allows you to have the numerical representation of your data as you have seen beforehand in the visualization with the pasta, right? That's what it builds up. It builds up vectorized data, vectorized formats of your data, which allows you like to do semantic search on it. Afterwards, you can see here, so you select the data source in S3, you select the embedding model, and you select the vector database where you store the data. You can choose between OpenSearch Serverless, Pinecone, and the Redis Enterprise Cloud for vector data. OpenSearch Serverless is the serverless version of our OpenSearch service, which is a very good fit for vectorized data, right? OpenSearch or Elasticsearch, if you're using Elasticsearch. And this is a question I've been having when I was discussing this with other customers or in other formats, like when do I use retrieval augmented generation? When do I go with fine-tuning, right? So with retrieval augmented generation, the users issues a query, it goes to a Q&A system or chatbot, whatever, that does semantic search on the vectorized data set that we've discussed earlier. The query and its result gets fed back to the large language models, which then issues the response which gets to the user. So that is the retrieval augmented query. With fine-tuning, the user issues a query. The base LLM, as I said, with its gigantic data set, it's fine-tuned with your specific data set, and the fine-tuned LLM answers that query. So when do you choose one? When do you choose the other? This is from a blog post that my AWS colleague, Heiko Hotz, he's an NLP specialist, has put out, RAG versus fine-tuning. So he recommends you run through this 6-pillar question, like, is external knowledge required for my use case? most of these LLMs like have a cutoff date in their training data. Most of them, because some of them are really up to date. But some, especially when you go for like a smaller model fit for your specific use case, there is a cutoff date in training data. It only goes back to, I don't know, a calendar date 2 years ago. So is external knowledge required that's up to date? Is model adaptation required? Do I need to the model to be able to respond to different queries? Do we need to minimize hallucinations, right? Am I building up a chatbot that responds to users from a bank or an airline system, or am I building up, something for creating content for kids, right? So is labeled training data available? Because for fine-tuning, there is, of course, the step your data scientists all know, right? Of cleaning the data, labeling the data, so that you can actually do the fine-tuning and validation on it. How dynamic is the data? How often it changes? And is transparency, interpretability, or explainability, as they say it, required? So these are the questions, right, that could help you decide between RAG or fine-tuning. But the thing is that you don't need to decide, right? You can employ both techniques. They're orthogonal, so you can fine-tune your model on some organization-specific data. So let's say it fits your company tone, right, when the chatbot talks to your user. And you can have it access your vectorized data, your embedded data for coming up with, I don't know, in the airline example, airline number and takeoff date. So it's not A or B. You look at what makes sense for your use case. This is something that I've been saying, that you access foundation models through a single API. So in the Bedrock Core API, that's just one method invoke model that you can use it to test out different foundation models. And you can see here an excerpt how it would actually look like. So I select the model ID. In this case, Amazon.Titan TG1 large. I have the parameters for it. So each of the models has a model card with the parameters you need to run it, similar to what you get on Hugging Face as well, right? So for example, for Titan, you get max token counts, top sequences, temperature, and top P. Are you familiar with temperature, top P, top K parameters? So temperature, the higher the temperature you have, the more, let's say, the model reaches out to answers that are less probable, right? The top P and top K selects only the first K words. Top P does a sum of the probabilities. So for example, if I have a prompt that says, I can hear the hoofbeats of, and you put out the LLM to autocomplete it. If you have a high temperature, you would get, if you have a 0 temperature, you get horses, right? That's the most classic example. If you have a high temperature, you would get maybe unicorns or coconuts if you're a Monty Python fan, right? If you have a high temperature and a low top P, top K, you would get maybe horses and zebras. So this is how you experiment with your foundation models based on what you want to get out of them. Now going back, these are the parameters. So I just run the invoke model API. I give it the body, the parameters, the model ID. And I ask, okay, how can I use generative AI model for my application? And this is what it comes back with as a response. You can run this in a response streaming way so that the model streams back the responses to you. So, like for example, you can use things that we discussed. You can use AI chatbots. You can use AI-powered image generator, text-to-speech engines, content creation. So it streams back responses that you can then stream back to your application. As I've said, each model comes with its own model card and its own set of parameters. So you can see for Titan, you've seen it right there. With Claude, you can set up top K, top P. Jurassic has like presence penalty for some words or tokens. You can set up. So it depends on each model that you want to run. Within Bedrock, you also have access to stable diffusion. So it's the text-to-image generator. I played around with it here. Like the prompt was dog in a forest. I had some negative prompts like, okay, no, poorly rendered, poor background, poorly drawn dogs in a photographic style preset. And it generated the border collie because actually I cheated before. Afterwards, I said border collie in a forest because I do have a border collie at home. So it's a bit of a creepy forest in the back. So I said, okay, let's do some image to image and add some leaves behind the dog, leaves around the dog. This was my change prompt. And I fed it the initial image as well. And you can see the result. It also changed my dog, right? So, and this is like where the business value for your applications comes in, right? Because I guess for those of you who have played around with stable diffusion, they saw that maybe some of the dog pictures have an extra tail or some extra fingers in their paws. And this has been solved out in the more recent stable diffusion models. I think for this internal model that I was using here, I was on 0.8. I think there's 1.0 XL available in Bedrock right now. But as I've said, this is the idea for Bedrock is to help out developers build your generative AI application, right? So when you would be building your application, I know we have like Adobe folks in the room, maybe you do your mask around the dog and you feed that to the model like in an image-to-image setting, so it just generates in the masked area, or there are things that you solve out on the application level. Here I have as well, as I've said, Bedrock was GA last Thursday, so I played around with it. It's available with all the SDK. Boto3 is our famous Python SDK, and this is how easily it is to interact with it. So you instantiate a client, right? A Bedrock client you choose the region, US East 1. I said, okay, generate a list of names for a fun brand of chili sauce. This is what I wanted my API to do. I have quite a high temperature setting and top K and top P because I want it to be very creative, right? I want it to have pretty interesting names. I choose the Claude V1 model, so I run the invoke model API. I choose the Anthropic Claude V1 model. I give it out the parameters that there were in the body. And then I format the response of the model because I've said it's just a JSON that gets back to you. So once I ran that, okay, you can see some name ideas like firecracker sauce, inferno sauce, blazing heat sauce, hellfire. So this is just how easy it is to play around with Bedrock API. And if you want, you can use the Claude model, or you can go and check what Titan model from our Amazon, this is our Amazon model gets you. So it's the same API that you use to play around with it. And there's like this famous, semi-famous mustard brand in Romania we have that have really interesting names for their mustard, right? I think it's a pretty cool thing that it allows you to put out names just like that. As I've said, security and privacy are like our priority, our job zero. So there's private connectivity between Bedrock and your VPC. Your data is encrypted both at transit and at rest, and the data you use with Bedrock is not used for service improvement, it's not shared with the third-party models, right? When you go to Bedrock, actually you have to subscribe to the third-party models from Stability, from Anthropic. Like it's like a marketplace, and you have to subscribe with that. We don't send out your data to the third-party models or anything. How do you get started? You can find the 3 QR codes. The first one is the landing page for our Amazon Bedrock. It's a one-stop shop for documentation. The second one, it's a YouTube tutorial that walks you through the features of Bedrock. And the third one, it's a hands-on workshop. It's just the workshop documentation, and it covers up a lot of use cases. Like you can build up chatbots, you can do search, semantic search, you can run image generation with it. So it's a really cool hands-on workshop, and I mean, we can run it together if you want to. Like, if there's interest in your organization for it and you want to test Bedrock out, reach out to me, reach out to my colleagues. So we're here, Radu is here. And we can find, maybe we will run a proof of concept together on Bedrock and how that would help you. How to start out, right? How to actually work with, to start learning about generative AI. There are multiple ways through which you can do that. We do have the skillbuilder.aws. So that's our platform for accessing AWS courses. But we also have this really interesting course we've developed together with Coursera. It's free. It's called Generative AI with Large Language Models. It's been developed by AWS together with Dr. Andrew Ng from deeplearning.ai. It's 3 weeks of course materials. For the free version, you only get the theoretical part. If you go for the paid version, you also get access to the SageMaker labs. To be honest, I did it like in 3 days, going through the theoretical part, because it's just very, very interesting, right? And it's very up to date, and it walks you through fine-tuning LoRa and PEFT and everything. So it's really good and really, really up to speed. So do try to tackle that. From my part, as I said, I've left the customer part out. I've left the pricing part out because I felt that this should be more of a technical presentation. But just to discuss a bit about pricing, there are 2 pricing models for Bedrock. The first one is very suited for POCs and testing, and you pay per number of tokens, right? So depending on the data you send, the data you receive, it's pay-as-you-go model for Bedrock. The second model is for production use cases, and it's based on a provisioned throughput that you want to run for running inference with your model on Bedrock. So how much capacity you would need to run that into production. As with all AWS services, the pricing is actually free. The pricing is free to see on our website. But for the throughput part, you should reach out to us to see how we can help you calculate that. So because estimating it for production is a bit more difficult than running the POC. As I said, I'm here. I'll be here throughout the day. So if you want AWS stickers or you have questions,
thank you.
I'm here.
Thank you so much, Cosmin. Round of applause for Cosmin Pascu. We still have some time for some questions, but before that, I want to thank you for the presentation, for the resources, and I have to admit to you that once you got to the coding part, I was exactly like that shrug emoji on your t-shirt. I wish I had gone to Politehnica instead of journalism school, so yeah, but maybe these guys in the audience are going to help me out, because I know a lot of you raised hands when previous speaker asked who's a developer.
Sorry to interrupt you, but when I was little, I wanted to go to journalist school, right? And my dad said, no, you should go to Politehnica, because if you go to Politehnica, you can be a journalist. Look at Cristian Tudor Popescu. But if you go to journalism, you cannot be an engineer. So here I am.
Wise parents. Wise parents. My parents told me I should go to journalism because Andreea Esca is rich. And yeah, true story. Right, so let's take some questions from the audience for Cosmin here. Any arms raised? No, now's not the time to not help me out,
I do
guys.
have a question.
Okay, do we have someone there?
Yes.
Yeah, thank you.
Hi, very insightful the presentation, especially about when to use retrieval augmented generation and when to use fine tuning. In terms of indexing the vector databases, supposing that you have a large volume, from the 3 options shown in the material, which one is recommended?
So, as I said, as part of the Bedrock...
The vector database options, yeah.
Well, my recommendation is that what I'm most familiar with is using OpenSearch. Using OpenSearch serverless, we've launched serverless last year, so it enables you to scale your OpenSearch cluster as per your needs, so you don't have to actually provision it. So my recommendation would be go with OpenSearch serverless, but then again, I am with AWS, and OpenSearch is an AWS service, so I may be biased. But as with everything, right, this is whatever I talk with customers, I always say, okay, you choose what is best fits your technology stack, what best fits your knowledge, your team, developers, and so on. So let's see what best fits your specific use case. But with regards to your question, I'll go with OpenSearch.
Thank you. Do we get another question? Okay. Oh, yeah, we have someone here in front. Allow me to give you my mic.
Are you going to implement large language models in Alexa?
Yes.
Are you working on this, at least?
Yes, we've had this announcement last week. We've had an Amazon Devices keynote, and we will be infusing large language models technology within Alexa. So you get like more deep, meaningful conversation, you know, not just intent matching or what you have right now. This has been, let's say, we're very responsible about the way we build our services and the way we productize them. And given the large footprint of Alexa, we want to make sure that, you know, the technology is there up to speed. We've tested it enough, so you don't get hallucinations in your bedroom or when your kid asks Alexa for a bedroom story.
Thank you. Thank you for the question. Thank you for the answer. I have a quick question since you guys aren't waving your hands. Are these tools like embedded in your internal processes? Do you use them or did you just build them in order to deploy them to other developers?
So our current Amazon CEO has said every team at Amazon is working on generative AI or using generative AI in some fashion right now. As I've said, machine learning has been part of Amazon's history ever, I think, almost from Amazon's inception. We had personalization, we had computer vision algorithms, right, for Amazon Go and our drone delivery business. We've productized a lot of our findings in machine learning as services for our users, so you can run the Amazon.com personalization algorithm with an API through the personalized algorithm. You can run recognition for objects or persons using image recognition using the Amazon recognition service. So a lot of the work we're doing, we're pushing that back to the customers. Even a lot of the work that, so I think this is still early, but what the team here in Romania is working on, like from a compliance and security point of view, they're doing state-of-the-art research and they're looking at way that they can push that out to end customers. So not just for Amazon.com as an internal customer.
Perfect, thank you. So basically you develop them for internal use and transform them into a product by themselves.
We always start with end customer in mind. We actually have a process for that. It's called the PRFAQ. So whenever you want to update a feature to create something in Amazon, there's like this whole document template that you fill out where a service is already launched. And you start developing a new service by writing the press release for its launch. So you always start from the backwards.
That's very interesting. Thank you so much.